The purpose of this lab was to determine the number of calories in a piece of food. Okay, to start off with the procedure, you're going to set up all the equipment to be used in your lab. Then you're going to measure out 100 milliliters of water to be placed in your can. After that, you're going to place the food on the paper clip. Once you place it on there, you're going to burn it, and you're going to have a partner measure the temperature change that occurs in the can of water. After that, you're going to input the data you've collected, the temperature change and such, into the calculations to find how many calories it was. Then you'll compare it to what the label says it is, and once you've done that, you'll clean up.
To begin our experiment, we need to hang an aluminum can from an O-ring stand. To start off with, we need to put a glass rod through the can. To begin, we punched a hole through the can with a corkscrew on either side. And then, after we have the holes, we make them big enough for the stir stick to go through with a pencil. And then once the pencil has pushed a big enough hole for a stir stick through, you simply slide it through both sides, and you can hang it from your O stand. To start your experiment, you need to have 100 mils of distilled water in your can. To get 100 mils, we took a graduated cylinder and filled it with exactly 100 mils of water.
Alright, so in the setup of this lab, you have an aluminum rod, like so, hooked up to the table. You'll have a clamp with a thermometer that you lower into the aluminum can that takes the temperature change, basically. Then you'll have a little glass rod, as was demonstrated in the previous video, through the can to hold it up. Then you have aluminum, like an aluminum shroud, surrounding it to prevent heat loss.
Alright. You are going to build a aluminum boat, which you can put your food on a paper clip here. And you want to make sure to get a pre-weight of the aluminum boat before you put the food on, and a weight after you put the food on.
Several hours later. Just kidding. But in all seriousness, it did take quite some time to burn. Alright, so as you can see here, this is the data we collected during the lab. The water temp before we lit the peanut on fire was 23.5 degrees Celsius. The final water temp was 54.4 degrees Celsius. The tray's pre-weight was 4.64 grams. When the peanut was on the tray, it weighed 5.64 grams, so the peanut weighed exactly 1 gram. The tray weight after the burn was 4.74 grams. The water volume was 100 milliliters, and the water mass was 100 grams because, well, the density property, I guess, and that is 4.7 grams. So for the calculations, I'm using the heat energy equation, and I'm using the specific heat of water to input into the data. As you see, Q equals M, which is mass, times C, which is the specific heat, times the delta T, which is the change in temperature. So since I'm using water, I have Q equal to 100 grams, since I had 100 milliliters, and according to the density, obviously, that's 100 grams. And then I have the specific heat of water, which is 1 cal over grams times Celsius, times 30.9, which is the temperature change, 30.9 degrees Celsius. And then you get Q equal to 3,090 calories, sorry for that. And then you simply, obviously that's correct, but that's also small calories. You have to put it into kilocalories. So your big calories, which is what you have for food. So you have 3,090 times 1 kilocalorie at the top, divided by 1,000 small calories at the bottom, which gives you 3.09 calories, which is food calories. And then, when you go to the label, it says there's 170 servings, and there's 170 calories per serving, 38 peanuts per serving. So I simply divide 170 by 38, and you get the number of, well, which is the number of then calories per peanut. And so you get 1 peanut equal to 4.47 calories. After you have that, you have the actual, or according to the label at least, the actual amount of calories in each thing. So then you find the error of your calculations. So you have your calculated value, which was 3.09, minus your actual value of 4.47, divided by your actual value of 4.47 again, times 100, which equals negative 30.9%, which means I was off, which means I was actually under the actual result by 30.9%. Alright, so in this equation we have 1 large calorie equal to 4.1868 joules. So since we determined that there was 3.09 calories in our peanut, the calculated value in our lab at least, we simply do a conversion factor of 4.1868 joules over 1 big calorie, and we simply multiply 3.09 times the number of joules, then divide by 1, which gives you approximately 12.9 joules. Alright, so the number, in conclusion, the number of joules that were approximated from the experiment that we performed were 12.9 in the honey roasted peanut. The number of calories was 3.09, and these are large calories. Then calories are significant because they're, well, basically how we run the human body. They provide energy and are important in the process of producing ATP biologically. And if you consume too many of these, you become fat because you store the excess calorie and energy. And the main source of error in this would have been heat loss due to a failure of our heat shroud made of aluminum.